welcome to the second developer community call. Before we get started, this session will be recorded. We had a few issues last time. This one will be on YouTube normally later today on our social media. If you are watching this after the fact, please come join us in our Discord. This is where all the action happens. This is where community calls take place. This is where the builders hang out. You can scan this QR code to join or check out the links in the description. I'd like to hand over the mic to Shaheen. You guys probably already know him if you're hanging out in the Discord. He will give us a little update on the community side. Shaheen, mic is yours.
Thank you so much, Max, and welcome everybody. It's so nice to see all these faces again on Discord. And yeah, this is our monthly game developer community call. So I have a couple of things to share. We are like almost 3,100 strong community members in this Discord group. Yeah, the numbers are just some metrics, but the bonds that we are building here, those bonds really matter to us. And to keep pushing in that direction, we have multiple initiatives for you guys, for everybody who is actively contributing in this group, every time who's engaging with other people. So as you guys noticed, we started with community awards last month. The last community awards was for the entire year, but right now we are pushing to make it a quarterly thing. So each quarter we'll be giving away these awards. So what are the categories? Let me just quickly go through them. Anybody who's building on top of Cartesi, there would be an award for you. If there are any people, any community members who are helping others in their work, in their progress, in their development journey, there's a Handy Helper Award for you. And people who are actively supporting, it could be non-technical support, it could be anything. We have an Active Supporter Award for you. And we have a Deep Diver Award, somebody who is very much into the tech, who's having deep technical discussions on Discord. So there's one award for you. So one thing that we would like to do this coming quarterly award is we want you to self-nominate yourself. So if you feel like you build something cool on top of Cartesi, yeah, reach out to me, self-nominate yourself for this particular category. Okay, this is about community awards. Then we have a big event coming up on February. It starts on February 24th. You guys might have know this, it's ETH Denver. So Cartesi would be there on ETH Denver. If you guys are going to ETH Denver, we have a USA channel on Discord. If you have any queries around that, feel free to drop your queries there. Feel free to say hi if you're from US, and let's build a great local community in there. And the last part I wanted to share was the POAPs. Can I get a quick yes if you guys received your POAP in the last call? Just drop a yes in the chat if you guys received a POAP in the last call, and if you guys liked it. How was it? So for everybody who's joining this call, we have a POAP for you, and I hope you're able to see this POAP, this amazing POAP on the screen right now. So, yep, super thanks to Shiani for creating this amazing POAP. Thank you so much, Shiani. And yeah, this is also one of those initiatives where we want to build these more stronger bonds with our community, and we really want to push in this direction and have some sort of these initiatives going on always. Thanks a lot. Thanks a lot for joining. Over to you, Max.
Awesome. Don't forget to claim your Pope later on. I also want to hand over the mic to Joe now. He's our Director of Labs. He'll talk a bit about our community grants program. Joe, floor is yours.
Thanks, Max. How's everybody doing? My name is Joe, and I'm the director of Cartesi Labs. And In the coming months, we're actually doing a lot to move towards decentralizing a lot of the efforts that go in, behind the scenes to select grants and source projects to award funding to. These projects that are using and leveraging the core Cartesi infrastructure and technology. These projects range from games that people and teams are developing to tools to interesting demos that others can build off of to even improving some of the core infrastructure. Now, the Community Grants Program, formerly it was called just the Cartesi Grants Program, but now we're introducing the community layer to the selection process. And this introduces transparency and also allows projects to get better feedback to bolster the proposal that they may submit to get funding for. So we have set up a snapshot space on which voting will take place. And this also introduces new utility to the CTSI token because votes for proposals the voting power is proportional to the amount of CTSI that you have staked in one of the pools, and you can do that through our staking portal. So this gives you another reason to stake your CTSI if you're just holding on to it. Now, we're going to be doing the public rollout of this in the next few weeks, so stay tuned for that. And we've also spun up a discourse forum on which these proposals will live, and that you can create an account and interact with other teams that are brainstorming projects and proposals. Also coming with this effort will be a revamp of the CIP program, the Cartesi invitation for what is it? I'm a little bit of a brain fart.
Cartesi improvement proposal. Yeah.
Thank you very much, Max. Yes, similar to EIP, but you can look forward to participating in a better capacity with these rollouts. So be on the lookout for those, and don't hesitate to reach out with any questions, or if you have a proposal idea and you want help getting started on that, we're here to help. Back to you, Max.
Thanks a lot, Joe. Yeah, really excited about this. This will really give you guys, the community, empower you, with your decision making as well. And we really hope that more and more, if you guys come up with some cool game ideas to propose. All right. Quick overview of the agenda. We will have an intro, which we're doing right now. We will go over updates from the games being built, and also a slight intro. So we did have intros last week. We will repeat a bit of the introductions for the new joiners, and also since we're recording this one, we will go over upcoming proposals, and then we want to open up the floor for questions and discussions. All right, so a little bit of repetition, why on-chain games are so interesting. I mentioned last week a few keywords: persistent worlds, collaborative building, which we're doing here, and user-owned and governed, worlds and assets and games. We can dive deeper into kind of these keywords and how you guys see fully on-chain games in a discussion session, but I just wanted to throw this out here. Also, quickly want to go over why on-chain games and Cartesi is such a good fit. As I mentioned last week, we see two main limitations that developers and obviously game developers face. One is, on the computational scalability side, and on the other side, we see problems with programmability. That's where Cartesi rollups come in. We have application-specific rollups. So essentially, you have your own virtual machine. You're not fighting with anyone else for block space, meaning you have, highest possible scalability, essentially, on a layer 2 for high CPU kind of games. And we have a RISC-V virtual machine, which means that essentially we unlock, all these languages, libraries that you're used to, build your games, and all these, run on Linux. So yeah, that was the quick little recap. Let's start building the future of games together. I'm really excited, all of you guys in the crowd today, and I'm really excited also to hear from our amazing speakers. I'll hand over the mic to Battleship team. Dimitar, please unmute yourself. Excited to hear what you have in store.
Sure. Can you hear me, guys?
Loud and clear.
Yes.
Just a second, let me share my screen. All right. So, as Max already said, my name is Dimitar, and I'm part of Productive. And together with Cartesi, we are working on a turn-based game on the blockchain, which is called Cartesian Battleships. The game is a recreation of the traditional Battleship board game, which is played by two players. Each player has his own fleet of battleships, and the goal of the players is to destroy the opponent fleet by guessing all the coordinates of the fleet battleships. And here is the representation of the traditional gameplay. Two players will have to arrange the game between each other. Once they start the game, each player will have to share the coordinates of the shoot with the other player. The other player will have to confirm whether it was a hit or miss. And at the end of the game, both of them will have to declare which one win or which one lose. This is a quick video of the game that we created together with Cartesi. The game is on top of roll-ups. So at the beginning of the game, the players will have to set up their boards on top of the Cartesian plane. And once they are done with the boards and the location of the battleships on the boards, the players will have to send the boards to the blockchain using the rollups. Then this information will be used for the verification of the game, so we can make everything fair and in general to make sure that everything is aligned with the rules of the game. So this is the gameplay. Once the game starts, each player will have to select a location on the board, and we'll have to send this location to the blockchain through the ropes. And this basically repeats until the end of the game. You see a couple of moves on the screen, and then the game will be fast forwarded till the end of the game where one of the players will be declared as a winner, the other one will be declared as a loser. So let me just leave it for a second so you can see the gameplay, and I will continue with my explanation. As you can see, each move is sent to the blockchain with MetaMask in this specific implementation. And also, as part of the interface, we have a kind of logs that represent all the moves of the players. And this is the fast forward till the end of the game. So we're not wasting that much time for the presentation. And this is basically the end of the game where one of the players is declared as a loser, the other one is declared as a winner. And both of the players will have to send their moves back to the rollups for final judgment and verification. So everything is basically confirmed and verified by the blockchain. And here is how the game works in general, just as a simple diagram. One of the players will have to create the game, the other game will join the game, and once they are done with the positioning of the fleet on the boards, the players will start sending moves between each other. And at the end of the game, one of the players will declare a win, the other players will declare a loss, and the blockchain and the roll-ups will have to verify the fair play of the game. And a couple of words regarding the architecture of the game. We have the Cartesi machine, and on top of the Cartesi machine, we have the Battleship game server, which is managing all the game logic. And also we have the Battleship game client, which is the browser game. And both of them are communicating using the notices, GraphQL, and Inspect API. And all these messages and all these transactions are verifying basically the gameplay and sending all the different transactions through the game. And additionally, something that we developed together with Cartesi the last weeks, it's something that we call internally instance server. This instance server is a kind of middle layer of the game. It sits between the game client and the game server. And the idea is to speed up the gameplay because with the traditional approach where each player move is sent to the blockchain with transaction, the gameplay is a bit slow. Each transaction could take like half a minute. In some cases, it could take even a minute. And in general, this slow down a lot the gameplay. So what we developed is an additional layer, which we call the instance server. And the idea of this layer is to have a communication with the blockchain and the rollups at the beginning of the game and at the end of the game. And in between, everything is happening peer-to-peer between the two players using this instance server and something that we call mini blockchain. And each player move is basically appended to the previous one as a kind of blockchain. And this chain is exchanged between the two players till the end of the game. And at the very end of the game, this information is sent to the blockchain for final verification. So again, we can keep the fair play and say if someone cheated during the game. And let me show you how it looks like in the interface of the game. With this version, we have the option to select the option to play the game with the instance server. Here, the game creation is sent to the rollups and the blockchain. So the initial setup of the boards of the players is stored on the blockchain for further verification. And once the gameplay starts, everything is happening within the instance server, and there is no communication with the blockchain at all. Everything is exchanged between the two players. And you can, as you can notice, there is no MetaMask or any other signs of additional transactions between the client and the blockchain. Everything is purely between the two players, which significantly improves the speed of the game and the overall user experience. I will just keep the video, it's less than 2 minutes, so you can see how it looks like with this version of the game. So the implementation of this instance server and the mini blockchain basically improves the speed of the turn-based games. And then the idea is basically to have a better game between the two players in real time. And something that we are planning is as part of this grant program that Joe already mentioned is to submit a kind of proposal for this grant program to develop further the instance server and create it as a separate module that could be implemented not only in the Cartesian Battleship game, but in any other turn-based game or any other project that has similar logic. So this is something that we are planning to make as a separate let's say a project, and it could be something that the rest of the community can implement in their own projects in the future. So yeah, that's it, guys. Let me know if you have any questions. My colleague Luchu, who is the developer of the game, is also online, so we can answer your questions.
Awesome. Thanks so much, Dimitar. If anyone has any questions now, feel free to unmute yourselves or type them in the chat. We can also keep these for the discussion session if you need some time to think about it. I think we can also, during the discussion session, dive a bit deeper into the state channel-like implementation. I think Theras is also working on something similar, and I'd love to kind of hear your thoughts and experiences around building those. Next up, we will have our next game developer, Dinder, Theras team. Teddy, Eric, if you guys are here, please unmute yourselves and let's get started.
Thanks, Max. Let me go ahead and share my screen.
Sounds good.
All right. Can everyone see my screen?
I cannot see it just yet.
Not yet.
Then
Nope.
Let me try again. It's not giving me any errors either. It's not.
Yeah, in the meantime, indeed, it does look like a normal game, Rare Zoo. Yeah, I suppose there's a lot of we want to make it look as much as possible as a real game, while having sort of these benefits of making it decentralized and stuff. But yeah, really promising game, and excited to see what's next with Battleships. I think a few things, Dimitar, that you mentioned, while Teddy's getting set up.
Yeah, about
early on,
the instant server, your game must still be playable when you have to go through the blockchain. So having a real-time game like Counter-Strike or anything like that doesn't work, because in case someone tries to cheat or anything, you have to fall back to the blockchain. And then an FPS game like Counter-Strike is not playable, right? So you still need a game like a turn-based game like Battleship or something like that, even if the experience is not that good because you have to wait for the interaction of the other guy through the blockchain, which is really slow, the gameplay doesn't suffer with it. So I have to keep that in mind.
Carlo, what are the drawbacks of this? Are there any?
It's just part of the nature of the problem, right? So the stage channel-like implementation is an optimization on latency when people are cooperating, but still, if you want to keep the logic decentralized, trustless, and yeah, you have to deal with this case in which someone is trying to cheat. And in that case, there are some situations in which you have to go to the blockchain. Otherwise, you cannot differentiate who's telling the truth or not. And when you do that, latency goes back to really high values that blockchain provides us.
Got it. Yeah, Edubard, regarding the technical details, I think that's definitely something that Acho and Dimitar could get into, maybe privately if you want, or if there's more interest, we can get into it later on in the discussions. Teddy, I don't know if you've had any success.
Not yet. Maybe let's go to this next speaker while I figure this out.
Yeah,
Sorry.
No problem.
No worries.
Blockchain, you wanna get started with Ultrachess?
Oh, snap, it's me, okay.
Yeah, I have to move things around a little bit. Hopefully you can share your screen.
All right. Let me know when you can see it.
Yes.
Yeah, I
You
can see it.
it?
So, everyone click on the
What about now?
See it.
Yeah, visible. Just have to
Perfect.
click on the screen, yeah.
All right, Ultrachess. The future of internet chess. All right, so here's some prior context, right? Right. In the current chess landscape, players are rewarded for their skills through like elo, right? So the better you play, the higher your elo, and the higher your elo, the more respect you gain. So Ultrachess is an attempt at adding an additional incentive layer to this landscape. All right, so what is it? It's a layer 2 dApp that allows its users to compete in wagered chess matches. With Ultrachess, users can choose to battle other humans, or they can deploy their own chess engines, right, to compete on their behalf. All right, so chess engines are stored completely on chain, and their ownership can be transferred, fractionalized, and traded between different addresses. Engines can also challenge opponents autonomously and win battles for their owners, right? Along with on-chain chess engine deployment, Ultrachess allows users to wager real value on all chess matches. Right, so, you know, third-party observers and can just place bets, right, on any sort of event that happens within the ecosystem. So on-chain chess AI, right? In online chess matches, cheating is prevalent, right? Via botting and other things, but the main thing is botting. And the intent isn't to like solve this directly by preventing users from deploying bots or using bots, right? But rather, we allow users to deploy bots, right? So we embrace bots in AI. Right, so each AI is basically a completely conscious being, right, with its own perspective, history, and goals and incentives, right? So they have their own objective to survive, right, by acquiring, you know, basically more money than they came in with, and more elo and more history and more trust, right, and respect, right? So yeah, interesting storyline. Right, so basically it's almost like a movie, right? We just sit back and watch the AIs battle against each other and entertain us while making us money. So here's a process of deploying a bot, right? So bots are basically UCI compliant, RISC-V executables, right? Meaning that all existing chess engines, right, that comply to the UCI protocol, which is basically all of them, right, can basically just be compiled to RISC-V or ported to RISC-V and deployed to our system without any difficulty whatsoever, right? So here's like basically Stockfish is a super popular chess engine, right? That works. AlphaZero, you can get that in there, right? Leela, Komodo, basically every relevant chess AI on the market basically already works. You can also program your own from scratch and deploy that if you want. And once you upload it on chain, you basically send your bot some funds, right? And then define your matchmaking preferences, right? The elo range, etc. And then define the sort of moves that you want your engine to make, right? Activate it and then sit back and relax, right? Okay, so on-chain AI marketplace, right? If you don't want to build, right, then you can buy, right? So you can buy these bots, right? Because they're NFTs, right? Bots can be placed within an open marketplace, right? Basically like OpenSea, but filled with assets that actually have value, right? Objective value, so no speculation. Each bot has an on-chain provable trail of history, right? And as a result of that, they have their own elos, match history, cash flow, and also like balance, right? So, right, some bots will be richer than others, right? So these are like important on-chain metrics, right? That allow third parties to perform due diligence on their bots and create reasonable evaluations, right? Which is, you know, that's good economics, right? So yeah, these NFT asset traders can potentially become a bigger part of the ecosystem than the players themselves, right? Is the idea. So currently there are companies dedicated to building open source chess engines with no direct ways of monetizing their efforts, right? And yeah, this is a value prop for that. All right, so why Cartesi? Because it's easy and performant. So it's easy to build on and highly performant. And also, it just makes sense for this sort of thing, right? Lots of compute is required for this sort of thing, right? And also, yeah, not just compute, but also, what is this, executional scope is needed, right? Or I need to be able to run a wide variety of different programs, right? Yeah, different sort of chess engines, right? Lots of different stuff needs to work on this. And the EVM is not, it's not gonna cut it. So support for UCI compliant chess engines like Stockfish, they can only run in, you know, a traditional sort of Linux or Windows or whatever base execution environment, right? So the essence of it all is to support arbitrary bytecode, right? So any piece of code that can be compiled to RISC-V and is UCI compliant, basically, will work, right? So users can develop their own bots in any language they want, however they please, function in whatever manner they please, meaning you can write a bot that performs terribly on purpose if you want. Okay, so the UX agenda is ease of use, right? So Ultrachess is gonna be as easy as, it's gonna be easy to use, right? Performant, quick, like a Web 2 app, right? Indistinguishable from a Web 2 application is the goal. You would not know that you are interacting with a blockchain if you don't want to, right? If you don't want to know. You can choose to opt into whatever level of savviness you want, right? Simply sign in with a Web 2 auth solution like Google, Facebook, or email. No transaction pop-ups unless you want them. And yeah, you can also choose to sign in with like MetaMask or traditional Web3 stuff. And also your wallet will be abstracted away from you as much as possible. So you don't have to even know your address if you don't want to. Okay, so this is like the gameplay. These are two different bots battling each other, right? One for Y41, whatever, has wagered 0 CTSI, right? Versus WRNN, who's also wagered 0 CTSI, right? At the end of this match, white wins, right? So if there was an actual wager, right now it's 0 CTSI, but if there was actual money, then this guy would win, right? He would be that much richer than this guy. Yep. Okay, some long-term ideas, right? So one idea on network design is providing value to basically all network participants, right? Not because it's righteous, but because it's optimal, right? Strong incentives create compounding network effects, and if participants can generate personal value from the growth of the protocol, it would encourage them to deposit more value into it, right? So yeah, for example, the main way that Ultrachess would probably accrue value is through a pot reward fee, right? Placed on all wagered matches. Maybe a chess engine deployment fee, right? On all bot uploads, and also a trading fee placed on like all bot trading and like chess piece skins and board skins, that sort of thing, right? And then the revenue of all that could be distributed to token holders or yeah, in many different ways. And yeah, a value can also be accrued to like a treasury, right? And then it could be managed by a DAO. Yeah, that's one thing is network design, right? And then another idea is conservation of energy, right? Within the application of itself, right? So mimicking the real world, right? Like it takes energy to generate a bot, right? So just like in Ethereum, right? In order to do anything, you have to sort of pay a gas fee, right? Just like in the real world, you have to pay energy, joules, right, to create a living creature, right? Yeah, that's the idea, right? Is to mimic the real world as much as possible. And then identity, right? So all users, bots, and entities can verify themselves on chain, right? So they can verify their names, nationalities, their ELOs, right? And then bots can also verify their source code, right? To make sure that their source code is correlated to their bytecode, right? So that you know, like, what sort of bot you're playing against, like the actual identity of the bot that you're playing against, whether you're playing against Stockfish, what comet, what branch, that sort of thing. And also chess matches could be NFTs, right? So yeah, your bots could be generating not only money for you, but also generating NFTs, right? And the winner of whatever match is probably gonna be the person that takes that NFT, right? And matches could be valuable to some people, I'm not sure. There could be a marketplace for that. Also, not just chess, right? All these, the essence of Ultrachess could be applied to basically any game. It could be applied to Go, it could be applied to a fighting game, it could be applied to a real-time game, basically anything, right? It doesn't have to be chess, right? Chess is just one game, yeah. Okay, so when can I play, right? So you can expect something live during around the ETH Denver time, right? Like live for everyone to play. And in the meantime, you can ask questions. I'm on Discord, right? I'm always on the internet. Yep, and that's it.
Awesome. This is some gigabrain shit, blockchain. Love it. Does anyone have some questions right away, or should we keep some for the end? Okay, I think let's keep some questions for the end then. And Teddy, I don't know if it works out for you now, but if you want to try it again.
Yeah, I managed to get to work after restarting Chrome. Let me share my screen.
Awesome.
Okay. You guys can see my screen now, right?
Still loading? Yeah.
Sweet. Okay, so I'm Teddy from Team Aethos. So we've been working on this Dinder game that's I would say it's a combination of a puzzle game with RPG elements, and that's a 1 versus 1 head-to-head. Not exactly like a fighting game, but there's elements from there. So basically, there's 2 teams of characters, and they take turns clearing pieces from a board to generate attacks to beat the other team. And each characters have different elements and skills, etc. So that's the gist of it. But so why do we want to put it on chain? So there's basically 3 main reasons. One's transparency, there's fairness, and for us, there's the benefit of having a provable RNG. So what we mean by transparency is that if this game state is on chain, then basically there's no way for people to deny the results of a outcome. And it's something that, say, if it's on a centralized server, then it's possible that the game could be rigged and nobody would know about it. So for, I think I basically just covered fairness over there. Provable RNG is, it's a big topic for games such, gacha games, especially with loot boxes that rely on RNG. And that's something that's a bit off topic, because this leverages the layer 1 chain our company has been developing to generate provable random numbers to prove that NFTs were fairly generated. So why use Cartesi rollups? So basically, it's great for the reasons that we just talked about. So mainly transparency and fairness. It's basically our competitive mode, or what we like to call our tournament mode, that we believe will be. Hope is that we could make it into esports and have tournaments that would be run using Cartesi rollups. That way that people are sure that the games aren't rigged. So for our goals, in short term, right now we're rapidly prototyping, and then we're polishing a version that we can showcase for the Denver event next month. And in a long-term goal, we're all like the Battleship team. We're also doing a instant server-like feature, basically a state channel to improve the experience on Cartesi. And similarly, we're also working on trying to make it into a library that could be reusable for different games. So right now, let me show a gameplay trailer-like video that we put together. So an idea that I think I've been talking with the Cartesi team, and I posted on the Discord channel like a few weeks ago, is that we're still wondering if it's something that we want to put into Dinder, or it's something that we want to do it as a different project, because it gets complicated when it involves a existing design. So the idea is basically trying to think of ways to different ways to use the Cartesi machine. So I know, like for Dinder and also for Battleship, we're using Cartesi rollups to basically verify the state of the game. So what if we instead use it to verify the state of a game engine? So basically, I'm imagining having a very flexible, customizable game engine, such as something like Minecraft, where it takes in commands or configurations to modify the game. And basically, the Cartesi machine would be able to verify whether a change is a legit change. And instead of playing the game on-chain, the game could be played off-chain. So the game engine version will be stored on chain, and players can download the current version and play it offline and play it as a traditional game, which could make things easier for traditional Web2 players to get into. So besides that, we're also trying to make the Texas Hold'em game that the proof of concept that Cartesi built a while ago, to make it into a production level game. So right now, because of technical difficulties with the mental poker algorithm, we plan to make it into a 1-versus-1 poker duel kind of game that will also leverage the state channel technology that we're working on. And that is it for our updates.
Awesome. Really cool stuff, Teddy. Really hyped about Dinder as well. It's a really cool game you guys are building. All right, I think it's time to open up for actually share my screen so you guys can check the agenda a bit more. So we did go over yes, my screen should be sharing. We did go over some of the upcoming proposals. If anyone else here has some, ideas of very early proposals or, games that you would like to build potentially, and you're willing to share some of the information already to get some feedback or, just to share it, now would be the time. We can do it, along the way, no stress. But let's get into, otherwise let's get into questions and discussions. There's a few topics that we wanted to kind of touch on. Kiko, I know you asked some questions in the chat. Maybe we could start with that. You wanted to know about the Unity dedicated headless server support and GPU support. Carlo, if you would like to unmute yourself, I think you have maybe some questions, some answers here. And Kiko, if you wanted to elaborate on these questions, now would be the time as well, if you're willing to.
Yeah, so as Shaheen also answered, there are a couple of ways to interpret this, and depending, might range from feasible to something not so easy to do. So the Cartesi machines needs to be deterministic. Otherwise, you cannot reach a consensus on which is the correct result of a computation. GPUs, not only by the actual implementation of some operations like floating points, things like that, but also because of parallelism and the order of things are executed, always change and are not deterministic. They're pretty much really hard to be used in order to have these deterministic computations. So accelerating things on GPU, it's really tough. We had a guide from the team that actually suggested we could have like a simple GPU device for some really limited use cases emulated inside the Cartesi machine. It's Eduardo, I think he's in here, by the way, so he can actually describe it a bit more. On another take on this question, what's feasible is actually developing a couple of plugins for specific engines so that it's easier for you to export the server-side logic inside the Cartesi machine. So we have a couple of interfaces that a game developer should comply to, and we can try to make plugins so that the actual game logic, which runs the game simulation, can be easily exported to the Cartesi machine. So I'm not sure if those are the topics you wanted to touch, but yeah, basically those are the areas I can see that we can talk about.
Yeah, so thanks for that. Yes, actually, I think that sounds good. Also, on the other hand, I've been looking into Unreal Engine because it also has C++ implementation and it has an open source. So I think I've had a few ideas on how to run that on a Cartesi machine and how to build games on that. Probably I'm going to be trying that out. But right now I've been working on having like a soccer simulation game. It's like an old game that was a sample in one of the books that's called Programming Game AI by Example. And I've been able to run this sample on as a backend on Cartesi and communicate with it to generate match results. So I guess the next step is to build or try the building a game, an Unreal Engine game into Cartesi, and try to have communication with that game through a front end. So the interesting thing here about Unreal Engine is that there is an option that the game wouldn't be using any rendering, so everything would be running on the CPU. And as I've mentioned, that Unreal Engine, it has the source code open, and you can actually get it and build. They have a process for getting the code and building it on Linux and stuff like that. So I guess it's theoretically it should be possible to build that on using the RISC compiler and build the game using the Unreal Engine, so that it would be running on the so that we can have games built using Unreal Engine running through inside the Cartesi machine itself.
That's a really interesting experiment. So it's going down to the details. It's beyond the time we have here. But if you can throw me a message so we can discuss it later, I'm really interested into it.
Yeah, sure. Yeah, I'll send you a message, and I'll send you a link as well of the soccer simulation that I've been working on.
Cool.
Yeah, awesome, Kiko. That sounds really cool.
Thanks. I had a couple of questions actually for Ultrachess and Dinder. So
Yes,
for Ultrachess, if it's possible to share like the high-level framework for the bots, how they're developed and deployed on the Cartesi machine. So is there a specific generic way that because I think that would be an interesting thing to use in many other games as well. So if there's like a generic framework that that could be used as a guide to for other games to use. So for the soccer simulation, for example, I think here the same idea could be used to develop bots as soccer players to play the game, and so I think it's it might be the same framework to use for both.
Oh yeah, so I got lucky with chess, right? Because chess already has this thing called UCI, Universal Chess Interface. So it's like a standard input-output interface that basically all chess engines or most popular ones implement. So I just implement that within the backend, and then just take in bytecode and then run it through that interface. But if you were doing something different, like you would probably have to implement your own sort of standard. But yeah, with chess it's easy because that it already exists basically.
Okay, I got it. Okay, that's great. Okay, so my second question for Dinder regarding the provable RNG. So is there like more info to share about that?
There is, but I'm not sure if it's a good time to share that right now because this is more about Cartesi, and I don't want to go off topic too much. So, but basically, we have a layer 1 chain that leverages a hardware chip generated RNG that can be proven that's generated by the hardware chip. That's the short summary of that. If you're interested, we could talk offline.
Yeah, okay, that would be great too. Thanks.
Awesome. Nico, do you have any other questions?
No, I'm good. Thank you.
Awesome. Just relating to your first question, blockchain. I remember your Street Fighter game that you had sort of worked on during a hackathon. Was there any, like, what were like the what standards you used there? Was it also sort of quite straightforward, or?
Yep. So that also was an existing sort of standard. So there's this thing called Mugen. It's like a open source sort of fighting game engine with its own standard for creating fighting game characters. So I just stole that, right? And it worked perfectly.
Sweet. Okay, that makes sense. All right. So those were Kiko's questions. Now, if anyone else has some questions, please unmute yourselves or drop them in the chat. We've had some really cool presentations here. Maybe we could dive into a little bit of the state channel and mini blockchain topic, Lacho Dimitar. I know this is also quite relevant to Teddy. Yeah, would you guys be down to talk about that one a little bit more?
Okay, hello there. I'm Lacho from Productive. We are developing the instance server of the mini blockchain. So I wrote a brief description in the chat, but anyway, we came with the idea of developing the instance server because the messaging through the blockchain appeared too slow for our game. The instant server is the implementation of the state channel. Actually, we write it in Node.js, and its sole purpose is just messaging between the players in a fast way that is off the chain and does not go through the blockchain in any way. It's fully separate from it. It also provides custom message validation for the purposes of the project needed. In our case, it's the rules of the Battleship game. So basically, this is the concept of the instant server. Regarding the mini blockchain, we came with this idea because when using this instant server, there is no verification of any kind because it's not on the blockchain, and any of the players can send false messages and forge the messaging history. And to prevent that, we came with the idea of this so-called mini blockchain. Idea is when players send a new message, they include the hash of the previous message, and this is formed like a blockchain of its own. This should be done on the client side. So we are developing this mini blockchain concept as a client library where the developer can use it at the client application. The idea is to support the most popular programming languages that should be used for developing games or applications. Additional feature is that actually the chaining of the messages is not only through hashes but also the player signatures. So each player, when chaining to the previous message, actually signed it its own private key, and then the entire mini blockchain can be verified if the signatures are correct, and this is proof that the messaging history is not forged in any way. So basically, this is the concept of the mini blockchain.
Awesome, Lacho. That sounds really cool. Eddie, do you have any comments or thoughts on this? Is this something that, in your case, you see any inspiration, or is this something? How do you kind of look at the state channels for now? I don't know if you've given a lot of thought yet. Just curious about your thoughts.
Yeah. So I know Carlo has been hearing us talk about it for a while, and interestingly enough, it sounds like our design sounds really, really close to what he just talked about. So we're still in the early stages, but our concept is very similar in the sense that we do intend to hash all the messages, and all of the messages have to be signed with a private key, so the other side can decode and verify that it's actually the other player that sent the message. And I'm not sure if it's the same, but one idea that we had was that since it's more of a state channel part, that the private key that the players uses doesn't have to be their actual blockchain wallet. So that way, what the player needs to do is to first register on the Cartesi machine what state channel signer they're planning to use, and then they don't need to deposit any money to this state channel wallet. They just need to use it to sign, and then once they're done with it, they could just wrap everything up and send it to the Cartesi machine, and then with using the actually it doesn't even need to be using their actual wallet because it's registered, so the machine actually knows who the messages are from and can just decode them. And also we're also using a instant server server, which is because we've already have a backend. We're basically just adding a relay server feature to it, similar to the instant server design.
Yes, this looks pretty similar to our solution. We are using this mini blockchain together with the instant server, which is our implementation of the state channel. Because when we are communicating on the real blockchain, we actually don't need this mini blockchain because the messages should be already verified. Similar to you, we are not using the wallet key, but we are using custom user-generated key pair for signing the mini blockchain messages. And this key is also already registered with the Cartesi machine at the start of each game.
Sounds very similar. I guess it's we both have very like-minded.
Yeah, if we can set up a call later, so put you guys to discuss the details, I think we can have a unified framework probably.
Yeah, I think that would be awesome.
Sounds great.
Oh, cool. Love it. See, Bruno asked a question, or is curious about the possibilities with combining OpenAI and gaming. Curious if anyone here has some thoughts about that. I know there's already some initiatives, using AI or OpenAI for lore development for games. In the case of NPCs as well, you could have like an AI you talk to that is sort of not necessarily controlled by the game, but it taps into this like more general AI. But yeah, curious if anyone has already dabbled around with AI and gaming. Yeah, feel free to unmute yourselves. The blockchain. I don't know if you have some thoughts about that.
I think getting OpenAI's gym within the Cartesi machine would be super cool.
Carlo, you have any thoughts on that?
Not sure. You gotta check dependencies, a lot of stuff, right? But yeah, it's an interesting experiment. One of the difficulties I have had was actually getting access to reproducing everything that they do, right? Most people, they just use a service that OpenAI provides and build on top of that, but don't actually tinker with the source code itself. One thing that I think it would be really cool to put inside the Cartesi machine, which is actually 100% open source and people are tinkering with, is Stable Diffusion. So generating art inside the game and stuff like this on procedurally, it's something that I think would be really nice.
But would that sit inside the Cartesian machine, or would it be like outside? Because I could also imagine like the game rules, being inside the Cartesian machine, and then maybe having some descriptions that generate kind of the lore and images using something like Stable Diffusion.
So depending on the characteristics of what you do with this art. So for instance, if you use that art for generating random characters, this art will also represent some properties it has, right? So on an RPG game, it could be a flying creature or some other characteristic, and you should reproduce that inside the game logic, which runs inside the Cartesi machine. So there are a couple of interesting thought experiments that should be performed in order to combine both.
Okay, and is it feasible to run something like Stable Diffusion inside of a Cartesian machine?
For this specific example I gave, it wouldn't be necessary. It would be more combining external execution with inside Cartesian machine logic. But
Yeah.
there are other applications that would be nice. So we have this media market generation using AI. And if you did it inside a Cartesi machine, for instance, you could reward people that actually generated the images that Stable Diffusion would use to generate that new art and reward them, right? Because these AIs are trained on huge data sets. And you could do this decentralized media generation service in which you actually give people that generated the data set a reward whenever it was used to generate some new art or stuff like that. I think it's something interesting to do.
Definitely. Yeah, definitely something missing right now, because I guess the data sets right now are just everything on the internet, but you don't really, like, the artists that created the initial art aren't really rewarded at the moment.
Yeah, in a centralized fashion, you don't have a good way to prove that your art was used or not as a training set, right? It's not provable. So if you do it inside Cartesi machine, then you have the transparency to actually be rewarded by this.
Yeah, for sure. Yeah, definitely some interesting things, like changes happening with the whole AI movement now. A lot of things can be outsourced, I suppose.
About your comment, Fabio, GPU limitations, yeah. As I said on the framework question, yeah, using GPU is a sensitive area because of reproducibility issues. But once again, it depends on how are you using, right? So in the game, the example I gave, the art would be used only on the front end, so no issues. The only part you would have to worry about is the characteristics it represented inside the game logic, which is easy to make deterministic. So it's a use case by use case discussion.
Definitely. Dimitar, I like that. Although you want to talk a bit more about your idea of Tetris. It could be a good discussion as well if you're willing to.
I was thinking about this idea. Traditional Tetris is a one versus one game, but including data from the blockchain transactions, you can generate a pool of a set of Tetris pieces, and you can make the other two players battle each other, and the one who wins can decide what pieces are passed to the partners. So this way you can translate one versus one game in a two versus two game that uses real data on the blockchain.
Yeah, interesting. Yeah, definitely. I like the idea of kind of using these old school games and seeing what would it mean, what could it look like if we brought these on chain? How do the dynamics change? I think there's a lot of we really like these old games, and I think bringing some of these back with some twists would be really cool. Yeah, anyone else have some thoughts about any of these topics? Tetris, using AI, and how AI and blockchain gaming can sort of collide.
The Tetris idea is really cool. The only thing is, should think about how the cheating part would go, right? Tetris is a real-time game, so if you depend on some data or some interaction from the other player to keep playing, and you have a situation in which you could claim like a timeout from the other player or something like that, it's tricky. Because once again, if you try to fall back to blockchain communication, in this case, then the game speed would be limited by the game interactions with the blockchain. And I don't think that Tetris would be much challenging if you have a lot of time to think about where to place your pieces, right, due to blockchain latency. But it's a very interesting idea, so I think there are ways it can be modeled so that this doesn't happen.
Yes, you're right. That idea can be used for Battleship as well, I think.
Yeah, definitely some overlap with we were talking as well at the beginning of the game with blockchain, like bit of overlap with like Game of Life, the Battleships. All these games do have some slight similarities, especially when you try to move them on chain with like infinite maps, those kind of things. Auction, I see you dropped some NumPy in there. You wanna talk about that a little bit?
Oh yeah, it's just a major dependency, like to getting some AI stuff into the Cartesi machine.
Mm-hmm. Fair enough. Anyone else have any topics they want to discuss? I know one thing I wanted to touch on is, again, sorry, Blockchain, I'm putting you on stage a little bit more because we had some talks. You mentioned some toolkits for building games, from client-side prediction toolkits, account abstractions, and stuff like that. Curious if you could elaborate a bit more, because I know you're really focusing on making the game as Web2 user, UX-ish as possible. And I know others are probably thinking about something similar. How do I make this as approachable as possible? So curious about like kind of the challenges you've seen and maybe these topics that we discussed a bit last few days.
Yeah, so any sort of framework or toolkit to abstract as much Web3 sort of stuff from the user as possible. Right? Also, client-side prediction type stuff for games that you want to appear more real-time. So basically, like the state channel stuff that they've talked about, that sort of thing, like making those sort of things public would be awesome.
100%. How would you suggest we can make these things more public?
First, I guess build a game first.
Yeah.
That's implementing all these things, and then, yeah, that will bring attention in, and then from there you just build the toolkits.
Yeah, that makes sense. Start with the games, and then we'll have some standards that come out of that. Definitely. Yeah, some other questions, thoughts. Like anyone, please feel free to unmute yourselves. I'm actually really curious about, in general, like ideas of, if anyone else, like Paolo, suggested like Tetris, but in general, Kiko, I see, MMORPG, yeah, that would be sick. Paolo, do you want to get into like would that be possible using an instant server? Yep, it can.
Yeah, once again, have to think about the game logic in case a dispute arises or anything like that, and you have to go back to the blockchain so that the game experience is not affected. So depending, you might shard the areas so that one area is blocked from the rest of the players because there's a dispute ongoing or some slow processing there. But then the other areas are available, right? If you think about something like that, then yeah, should be feasible.
Interesting.
Hi, I have a question. So I'm not sure if this has been asked already. When can we expect mainnet? And secondly, what's the difference between these games being built on testnet versus mainnet? Would we just be waiting for mainnet for them to all become public, or is testnet really just a beta phase? Thanks.
So Web3 systems are really complex, right? Basically, all of Web3 systems are built so that you don't have to trust and things still work out. So there are a lot of complex mechanisms involving economic incentives and other stuff, so that there's no way that someone can do something nasty and get away with it. The part of no way someone can do something nasty has multiple parameters. So just give you an example. On the Cartesi rollups, when there's a dispute and you have to arbitrate it, you put a collateral in there. And that collateral is something you lose in case you're wrong. Let's say you're doing a dispute on a poker game. If the stake at poker is higher than the collateral, the validator might just collude with the player, lose the dispute on purpose, and then split the stake. So all these details, they're really tricky to get figured out. This is just one example, one particular situation. But figuring this out is hard. You have to stress test all of this. You have to do a lot of crazy thinking in order to identify corner cases that people can try to exploit it. And basically doing this is one of the great reasons why we have testnets. It's you put the things out there and you allow people to try to cheat and to try to find a loophole in an environment in which you don't have economic issues. Because all the testnet tokens, they're fake, right? So if someone pulls out an attack and steals a stake from your game or anything like that, well, they just didn't cause any damage. And I think that also goes into the direction of asking when mainnet. So there's no exact date or timing for that, because when mainnet is basically when we feel it's good enough, it's ready, it's stable enough. Whenever you go to testnet is a point in which we think, okay, so seems like we have something that's a good candidate. Now let's stress test it. Let's see if it makes sense. Let's pick up feedback on usability and other things that we don't have a wide testing on that when we are doing some more private development. Let's put it this way. So yeah, it's it's something that depends. If all the decisions we made during development are nice for the rest of the community, if no big issue, bug, corner case is found, anything like that, then it's something that goes faster. If we have some major change that has to be done, identified, then it gets slower. And also something that happens when you're on testnet before going to mainnet, which takes a lot of time, is external audits, right? Because it's a complex system, and you have someone basically crash landing on it, having to understand what's going on and trying to figure out if there are security problems. So that's something that takes a lot of time.
Okay, that makes sense. And thanks. And in terms of like these bad actors, right? Like if I was a bad actor, for example, I would just use small amounts to identify an issue, and then when mainnet's live, then execute on a larger volume. Like what measures are like, are you guys looking at a materiality basis, or like, are you guys just picking up any anomalies? Like, how does that kind of work in terms of your testing? Are you picking up all errors, or only looking at any material ones? Like what's the approach?
There's no single approach. There are multiple things. So sometimes you analyze the logs and the transactions, everything, to see if everything is going as expected, or if there's a weird behavior in there, like an interaction that should have reverted or should have been refused, but it's being accepted. A lot on this protection is having good tests. So something that's put a great amount of effort when the product stabilizes is expanding the amount of tests you put on the code, because that's not only gives you a guarantee that that version is working fine, but when you do changes in the future, that you're not introducing known security issues or bugs, right? External auditing is always a good idea. For a long time, we've had this Immunify bug bounty program, which is also another front, because there are a lot of white hat hackers out there. And there are also gray hat hackers, right? So if there's some incentive, they go to the white side. If there aren't, they might just pull out an attack. So that's also an initiative to try to make things manageable, right, and not incentivize people to actually attack the system in a damage way. And yeah, all the developers that are using the system, they generally also do some scrutiny themselves. So it's not a single strategy, it's just a large amount of different efforts that converge on this objective of having things secure, bug-free, and error-proof.
Okay, thank you. And sorry, one last question. Like, how would you rate the system at the moment? Like, Cartesi, like if you were to put a percentage on road to mainnet, where do you think we are? Do you think we're 50%, 75, 90? Like, where do you think we are right now?
Yeah, so we release those kind of smaller granularity percentages of all the things we think should be reached to go to mainnet. And I would suggest you check on those reports we do monthly, because all these percentages, they're extremely thought when we put them in there. It's not something that we can come up with a number like out of the blue in 30 seconds. It's a complex thing to do.
Okay, but do you think in terms of like games, we have like Ultrachess? I think you guys have been talking about that for a while. Do you think we can start playing with demos soon, or like do you think is still a lot more testing to go, or any other game for the matter? Because I don't think we've seen any demos we can play with at the moment, like in terms of just download and play.
Yeah, hopefully, if Denver will have some public alpha releases that people can give it a try. So I would say that's
if Denver is
a possible first target, end of February.
Okay, and sorry, but yeah, for Denver, is that like all these three demos, the Ultrachess, Battleships, and Dinder? Is that the three, or just Like, is that the target? These demos be available then?
The target's having some demo, like not a full demo. You know, on E3 when you have these like one-stage demos or things like that, like a teaser, that's the kind of thing we're aiming for. It's not the full game itself.
Do you think it's better to have a full game and then to get people excited than have a little bit teasers of many different games?
There are different teams developing, right? So there's a sentence that I like a lot that 9 women don't make a baby in a month. It's something like that.
I like the questions, Crypto Gambler. They're good questions.
No, I appreciate the answers. I guess as an investor and a long-term supporter of this project, like many, we're just very keen to see something tangible. We see a lot of progress in the background. We like to see something on the front end we can play around with.
We'll have some games soon to play, and really excited about that. And we do want to get the games out early so we can all, start playing with them, and also potentially getting the community involved and, sharing some feedback and maybe co-building stuff, of course. So definitely some good points. I think we're at the end of this call. Thanks everyone so much for joining. A few more things, like please share any points you guys would like to discuss in future agendas. We'll have like another, thread open for you guys to share stuff. We also want to have like an informal, open game study group, where you can play Web3 games and Web2 games together. Obviously Cartesi games once these are live, but before that, just have fun, get inspired, and see what works. If you guys are interested in participating and playing some games, in an informal way, please send me a DM. And yeah, obviously, please claim your Pope. In order to do that, please send Shaheen a message, a link to your Pope. Get that in your wallet. And thanks again, everyone, for joining. The recording will be also on YouTube later on. We'll share the link as well. So talk to you soon, and thanks again.